Hello. Today we'll be doing linear regression and multiple linear regression. Simple linear regression first, and then move to the multiple one. Okay. Let's start with the coding part of it. All right. This is a linear regression. Today we'll be doing the simple one, simple linear regression. We'll be talking about the multiple linear regression. We'll be talking about the R-square, which is the coefficient of determination. It tells you exactly how good is the model. Okay, and we'll be seeing some of the loss functions like the MSC, RMSC, and so on. Okay, let's go straight away to the point. First of all, we're going to import the pandas. We're going to import all these libraries. There's going to be the pandas, NumPy, always the plot stuff, the PyPlot, which is the PLT here, the Seaborn, which is another library sitting on the top of Matplot. Okay, and then we load the data. The data we have here is the real estate data, and we have the data here. It's called the housing-data.csv. We'll be sending you this data in the with the files. Okay, and the data consists of, we'll be trying to predict the price, and the price is a function of the square feet, which is the surface of the house, the number of bedrooms, and age of the house. Okay, you have all the information here. And here what we're doing here, we'll try to explain to you this code here. This code here is going to reduce the price from thousands to hundreds, maybe. This one is very high. Would like to have a price, reasonable stuff here. It's not going to change the prediction at all. Instead of dealing with something very high values here, we're going to make it very close to the the price. We're going to make it quite close. Okay, it's not going to change. We reduce the price by hundreds, divide by thousands in this case here. You divide by 1,000, this one is going to be 399, this one is going to be 329,000, etc. So this one is not going to affect exactly the price. Okay, we know we have divided by 1,000, so it's going to be what we're going to predict this price function, first of all, of the square feet or number of bedrooms or the age. So it's going to be x function of y function of 1x. Price is going to be a function of the square feet, for instance, okay, which is a simple linear regression. And then we have we divide the price here by 1,000 here. We have the square feet, the bedrooms, the age, exactly the same. And the model is going to look like something like that. We have the y, a function of x, and x here, we have chosen square feet. You can choose anything you want. You can try with the number of bedrooms. You can try the age. It's not going to change. Okay, so we're going to have different models. That's all. Here is going to be equal to beta 0 plus beta 1 square feet plus the error. The error here, which is going to be the difference between the predicted and the real value of the price. Okay, because keep in mind, this y is price, a function of the square feet, and this is a linear regression here, a very simple one, plus the error. Okay, and the beta 0 here is going to be the intercept. Okay, and the beta 1 here is going to be the tangent, or is going to be the slope of the line. Very simple one. Now we have the price. The target is going to be the price, and the predictors or the features is going to be exactly the square feet. For your information, you can change it into the number of bedrooms if you want. You can change it to age, and you do exactly the same calculation, exactly the same. And should be this is the final equation. Okay, y hat is going to be the predicted equal beta 0, the intercept, plus beta 1x, and beta 1 is going to be exactly the tangent, or is going to be exactly the slope of the line. So we calculate here, we define here is going to be a function. It's called the calculate y hat. We're going to calculate exactly y hat, which is this one, right? Which is a function of beta 0 and beta 1, and we return it. So this is a function here, okay? And we write exactly another function is going to plot everything. It's going to plot exactly the line with the dots, with the data, okay? So if you want to understand line by line, please take this one and put it into ChatGPT and write explain. Please explain line by line. It's very easy, very easy. And this is going to calculate the y hat, which is this one, okay? And the rest is going to be exactly the scatter plot and so forth, the minimum, the maximum, and so forth. Okay, and at the end of the day, we'll be having plot.show. It's going to show you exactly what you're going to calculate. Okay, so this is one way of calculating exactly the beta 1 and the beta 2. Okay, this is one way calculating the beta 1 and beta 2. We can do this without getting involved in all this, but I'm going to show you this later on. Okay, when you do the modeling part. When you do the modeling part, you can predict within the modeling part beta 0 and beta 1 without going through these functions. Okay, without going through these functions, guys. All right. So I'm going to show you later on how to get beta 1 and beta 2, okay, without going through these equations and so on. This is exactly, I'm going to show it to you, the concept, how it works. Okay, and this is how to calculate the beta 1, and this is how to calculate the beta 0 here, and we return y, the mean y equals the beta 1 mean x. Okay, so please, if you want more information on that, if you want to take this and take it to ChatGPT, please explain. And the explain is going to explain to you y by one, line by line. All right, and then we calculate the beta 1, we calculate the beta 0, and we calculate, we have here the beta 0, the beta 1 here, and we have here, the beta 1 here, and we have here the beta 0 here. Okay, and this one, the beta 1 is going to be what? Is going to be the tangent, which is 71.27, which is the slope here. Okay, and the beta 0 is going to be the intercept, which is 0.13. Okay, 0.13. Okay, and this is exactly what we plot here. We have plot, this is the data, and this line are the fitted line into this one, and this is the calculated predicted one. Okay, what you see in red dots here are the calculated one, which is exactly, I'm going to show it to you, which is this one. Okay, the y hat are the red ones. Okay, and the blue ones are the data given here. The blue ones are the data given, I'm going to show to you the data given here. Okay, because it's the price versus the square feet. Okay, guys? Okay, that's fine. Can calculate at the same time the R square, which is the coefficient of determination for the simple linear regression here. That's the different equations, how to calculate that. That's we have to calculate R square. Once we do the modeling part, you don't need to do all this. Okay, it's you put just a simple code. You ask them to print for you the R square. You ask them to print for you the beta 0, the beta 1, and the model will provide for you all this the coefficients, the intercept, the slope, etc. So this one is it's more difficult. Okay, it's more difficult, but I would like you guys to understand the concept, how it works. Okay, and this is exactly what we are doing with the R square, and the R square here is 0.73. Okay, which is not bad, actually, which is not bad. We're going to compare this one with the multiple linear regression. This is for the simple linear regression here. Okay, now we tackle the multilinear regression here. If we tackle the multiple linear regression here, first of all, what we have done so far is price function of the square feet. Now we're going to do the price function of the square feet plus function of the number of bedrooms plus function of age, which is multiple linear regression. Let's move on. Okay, fitting the multiple linear regression here. is going to be exactly the y hat, beta 0, the intercept, beta 1 x1, beta 2 x2, and beta 3 x3. Beta x1, x2, x3 is the number of bedrooms, the area, and the age. Okay, and the beta 0 is going to be the intercept. We're going to see here later on with the beta 0 here for the intercept, because it's a three-dimensional stuff. That's going to be a plane. Okay, so the plane is going to cut exactly the y in a certain value called beta 0. We'll develop this later on. All right, so that's the theory behind it. Okay, now we calculate what we have, the household. This is exactly the data we have. We have the square feet, the bedrooms, age, and the price is a function of all this. All right. And this is exactly, we assume the intercept is going to be equal to 1, and then we calculate the square feet, the coefficient of this, and of this. And as you can see here, we have the intercept equal to 1 here. And we have for the first, we have the first 3. We can have 5 or 10. It's up to us here. Let's do 7, for instance, and we calculate every time the square feet, the beta 1, beta 2, and beta 3, based on this equation here. Okay, beta 1, beta 2, and beta 3. And these are the values of beta 1, beta 2, and beta 3 for this point, for the second point, for the third point, etc. At the end of the day, we're going to have an average value. Okay. Then we're going to print exactly. This is the modeling part, and this one we'll be seeing this later on next session or next video, please. This is the modeling part, how to choose the model. Okay, this is just how to choose the model, and the model. A linear regression model, it has been chosen from sklearn.linear_model. We import it and we fit it. Once you do this, we see later on we can calculate the coefficients, all the coefficients we want. Okay. Now the coefficient has been calculated through a most difficult approach, right? So later on it's going to be a lot easier. And then we can calculate exactly the coefficient here. And as you can see here, we're going to see it in a more challenging part. And okay, once you import the linear regression, you can fit it first, and then once you fit it, you can do the predictions. So we fit it. Once we fit, we can exactly get all the coefficients. And you can see we have all the coefficients here without doing all this. Okay, without doing all this. Okay, so it's very interesting here to see here. We have from sklearn linear model, import linear regression, and we calculate fit intercept equal to false. Okay, not equal to 1 as we have done before, and then based on that we can calculate that's intercept, that's beta 0, that's beta 1, and that's beta 3. A lot easier. You can see here in a couple of lines here, we can calculate all the coefficients and we can predict anything we want. And again, we calculate the R-square here. You remember the R-square before, it was 0.73, and the R-square here for multiple linear regression is equal to yes, it's exactly the same. It's always the same, it's 0.73. Then there is no the R-square is still exactly the same. Okay, this is one approach. I'll recapitulate again. First of all, you guys, you're gonna import the data. You set the libraries first, you import the data, and let's try do one try. We assume it's a simple linear regression. With a simple linear regression, the price is a function of square feet. Okay, so what you can do to practice more, you do it the price function of the bedrooms and then the price function of age. Simple linear regression, and you can follow exactly these steps here, and you get exactly the result you want. Okay, and then you calculate the B0, the beta 1, and etc. right? This is the most difficult part, okay? This is the most difficult part. We can plot exactly the data, that's in blue, and we can plot the predicted data and the difference between the predicted, okay, the difference between this dot, for instance, and this dot here, the difference here is going to be the error. For each data point, there is an error. And the data point and the error here is going to be this one, is going to be exactly the error we have shown you before. Okay, that's the error here. There's another error somewhere here for the equation. Okay, for the simple one, for the more complex one. Okay, and then we calculate exactly the R square. The R square for the simple linear regression is 0.731. For the more complex one, multiple linear regression is 0.73. 0.733. Okay, this is a little bit better. Okay, it's a little bit better, but still is still in the range. All right, this is number one. Okay, number two, guys. Number two, guys, is going to be another one, which is this one. Sorry, guys. Number two, guys, is going to be another linear regression. Okay, so we import data, we import the pandas, NumPy, Seaborn, etc. As you can see, all this data is part of the data set within Jupyter, right? This is ready already. You don't have to look for them. If you want to, for instance, in this case here, the one tips here, the tips is here. Okay, you can take another type of data. You can call it gray cell here, and you have the data of gray cell here. All right. So I will advise you guys. You're gonna practice it with tips, and then you can change it to blue. You can change it to diamonds and so forth. Okay. So the data you actually have here, you have the data that's tips, total bill, tip, sex, smoker, day, time, and the size. As you can see here, size. This is tip, and you can see here sex, smoker, day, and time. All of them are categorical data. Tip, total bill, and size are numerical data. So what we're going to do later on, we're going to convert the categorical data into numerical data. Okay, so you have the X here. The X here is going to be tip, right? The X here is going to be tip, and the X is going to be, and the Y here is going to be dividing data into features. So we're going to drop the tip. Okay, we're going to drop the tip first. Okay, and then we're going to have the Y is going to be equal to tip. Tip is the one we're going to predict. All right. Okay, based on the total bill, based on these factors or these features here. But we cannot predict unless we're going to convert first. Exactly, we're going to convert this data or this category data into numerical data. Okay, so we know we're going to predict exactly the tips. So we're going to drop these data, these ones here. Okay, we're going to drop them, and we're going to have the total bill versus size. All right, and this one, we're gonna these data sex, smoker, day, time, exactly. So we'll be converting them using dummy variables. Dummy variables, you can use it only if we have categorical data. We want to convert them into numerical data. Otherwise, they're useless, right? But it's very important to have this data part of the modeling part. Okay. So we have discussed before the dummy data, and we want to convert exactly the dummy into the dummy variables can only be used with categorical data. We assume the categorical data is already defined and contains your categorical data, which is this ones. Okay, and then we pandas dot get dummies categorical, which is defined already. Okay, categorical. We drop exactly the first one. Drop exactly the first row. Exactly. And then for more information on all this, please cut this one and put it into the ChatGPT, And it's going to explain to you line by line what does it mean. Here, we're going to convert the Boolean value, true or false, and then we're going to display the first few rows of the data frame. This is the first few rows of the data frame. Okay, and sex female is going to be 0 or 1, smoker 0 and 1, etc., etc. Okay, and then guys, we be having the whole data is going to be this total bill, size, sex female. As you can see here, the data are converted from categorical to numerical, and all of them are here. Okay, and then we can implement the train test split. You remember the train test split, the data is going to be one set of data, and the data is going to split into train data and test data. And the train data and test data, we're going to take the train equal to 80%, and this test data is going to be 20%. All right, so we X train, X test, Y train, Y test equal train test split, and the train test split is here. We're going to import it. Okay, we're going to import it from skitty model selection, import train test split. We're going to find it again here. Okay, so we split the data into 80%. 80% is used to train the data, and the 20% is used to predict the data. Okay, we'll talk again about the feature scaling later on. Okay, later on, not very important at this stage. And then we can use exactly the, we're going to talk about it now. And feature scaling, we discussed it. It can be normalization or it can be standardization. And then we can import this feature scaling, whether normalizer or standard scaler. It's up to us, all right? It's up to us. In our case here, we're going to import it as standard scaler, which is a standard scaler here, which is this one here, which is this one. You don't have to calculate through this, but the model will calculate through this. Okay, so this is from skitty-learn pre-processing import standard scaler, right? Or if you want to try it with normalization, you can do both and see exactly what's the difference. Scaling, you do the transform, you transform only the features. You don't transform, that's why you transform only the features. Don't transform the target. All right, keeping this in mind, the transform is you feed the transform, is you do it only with the features. And then we do the transform at the end of the day. Okay, and here scalar, the test. You scale the test, transform. Okay, here the fit, transform, okay, because you're going to fit into the X train, and then you do only the transform for the X test because it has been split into training and testing. Okay, training and testing. So the fit transform with training data, and the only transform is going to be without the fit is going to be the X test, because the fit here is going to fit exactly the X train data or the training data. And then you do the linear regression as usual from skitty-learn linear model, import linear regression. Okay, and then you train the algorithm. That's the algorithm, we call it, you can give any name here. Okay, and linear regression, between brackets, and the regressor is going to be linear regression, this one. Okay, dot fit, you're going to fit first, I'm going to predict later on. You're going to fit X train, Y train, and then you're going to make some predictions using the X test. Okay, using this one. All right. So, and then you're going to have, I'm going to show you here some of the errors. You can calculate different errors. You can calculate exactly the mean absolute error. You can calculate the mean squared error, and you can calculate the root mean squared error. You can calculate all of them, but I prefer myself to calculate exactly the mean squared error, which is 0.94%, and which is 0.94, which is exactly 94%, which is very high. What does it mean? This model works exceptionally good. It's very good. Okay, the fitting is very good. Okay. Now, after showing you these guys, you can try with the diamond. You can go back exactly. You can go back and try with the diamond how it's going to work, or you can try with the something else. I don't know, the flights. You can try with the health. having experimentation. You can try with the iris data, you can try with the penguins, you can try anything you want. So I will advise you guys, first of all, is to try with some of the data. In this case here, you can try with Demon, I can do something else, okay? But please give it a try. So these two examples showed you briefly how to work, how to get exactly the linear regression, simple linear regression, and the multiple linear regression. Keep in mind the simple linear regression, you have one beta 0 and one beta 1, full stop, okay? Because it's very simple. The more complex linear regression you have, which is multiple linear regression, you have the beta 0, which is the intercept, you have the beta 1, beta 2, it depends on the number of the features, okay? So keep this in mind, and I showed you some modeling here about how to do that. It's very simple, as you can see, it's very simple. And based on that, we can calculate the beta 0. Based on that, we can calculate the beta 0 and we can calculate the beta 1. If you go back to the last example here, okay, so we calculate the beta 0 and the beta 1 here. It's quite complex, but if you do the modeling part, you calculate straight away the beta 0, the beta 1, etc., like I showed you before. Okay, let me show it again. Okay, now like here, exactly. Okay, like here we have, sorry guys. Okay, and here we calculate exactly we calculate here the coefficients of the beta 0 here, beta 1, beta 2, beta 3, and 4. Okay. Okay, this is finished. Okay, and see you next time in more interesting code to show you exactly how more complex code works. Thanks very much. I appreciate that.